Has the well-established question of whether our species is extraordinary in the universe at last been addressed? We may be drawing nearer to a game-changing finding thanks to the James Webb Space Telescope, presenting K2-18b, a distant exoplanet that has recently become a focal point in the field of astrobiology. Why? Its atmosphere contains an anomaly that the James Webb Telescope discovered, which may indicate the presence of life. The molecules that make up water vapor, methane, and the very rare substance dimethyl sulfide aren't entirely random. Perhaps these are the biomarkers that have been puzzling scientists for so long, suggesting that extraterrestrial life may indeed exist. Our new guardian of the cosmos, the James Webb Space Telescope, JWST, is equipped with the most cutting-edge space hardware ever built. Its purpose is to delve into the unknown and potentially redefine our concept of existence. The mysterious world of K2-18b might be one you're ready to explore. We rely on telescopes and other technological marvels to sharpen our understanding of the universe as we venture further into space in search of answers to mysteries that have perplexed humanity for millennia. Among these, the James Webb Space Telescope stands out. We owe a great debt of gratitude to the Hubble Space Telescope for decades of providing us with breathtaking, enlightening images of the universe. However, even Hubble has its limits. Enter the James Webb Space Telescope, a telescope whose mission is to expand our understanding of the universe through the power of light. The JWST's cooling screen technology is among its most remarkable features. The size of a tennis court, this intricate technical marvel blocks the heat of the sun, earth, and moon, acting as much more than a mere sunshade. How is this vital? It allows the telescope to be cooled to extremely low temperatures, making it more sensitive to faint infrared signals emitted by distant stars. Exoplanets like K2-18b can only be studied through the use of infrared observations. Space dust can block or scatter visible light, but infrared waves can pass through it, allowing for much clearer and more detailed images. Infrared observations, made possible by the JWST, represent not just a milestone but a game-changer for our understanding of distant planets. What new information might we uncover as our attention shifts to K2-18b? Located 124 light-years away in the constellation Leo, this planet resides in the habitable zone around its star, a region characterized by temperatures that are just right for liquid water to exist. K2-18b follows a similar orbit around its parent star, K2-18. But how is it different from other exoplanets in comparable orbits? Scientifically speaking, K2-18b is classified as a Hycean world, not your typical rocky planet. The discovery of habitable worlds with an oceanic surface and a hydrogen-rich atmosphere marks a new chapter in the search for alien life. Recent studies by the James Webb Space Telescope have revealed new information about K2-18b's atmosphere. The atmosphere of this distant planet contains various gases and elements that could potentially support life, or at least life as we know it. These include water vapor, methane, and possibly even dimethyl sulfide. The scientific community is thrilled about the discovery of these atmospheric components. Researchers are abuzz with anticipation and speculation as they contemplate what these findings could mean for astrobiology and the search for extraterrestrial life. The unique atmospheric composition of this Hycean world raises the intriguing possibility that it holds the key to understanding life beyond Earth. What does the future of astrobiology hold? Considering its exceptional conditions, one of the most challenging yet potentially rewarding aspects of exploring extraterrestrial planets is learning about their atmospheres. The unusual atmospheric composition and distinct habitable zone status of K2-18b make it a compelling case study for how exciting and fruitful these types of investigations can be. K2-18b presents a completely different environment compared to Earth. While Earth's atmosphere consists primarily of nitrogen and oxygen, the hydrogen-dominated atmosphere of this exoplanet is rich with scientific mysteries. Studying an alien planet's atmosphere from over 100 light-years away is no easy feat. Spectroscopy, a technique that analyzes the transmission of light from a planet's parent star through its atmosphere, is used in this process. By examining the unique fingerprint created when different molecules absorb light at specific wavelengths, scientists can infer the composition of the atmosphere. The James Webb Space Telescope's infrared capabilities were critical in these discoveries. Thanks to its mid-infrared instruments and extended wavelength range, chemicals that were previously difficult to detect are now within reach. Scientists are considering what types of life could exist in K2-18b's atmosphere based on the abundance of methane and the absence of ammonia. On Earth, biological processes often produce methane, so the detection of this gas on K2-18b raises the fascinating possibility of previously unseen living organisms adapted to a hydrogen-rich environment. Furthermore, a subsurface ocean might exist based on the atmospheric composition and position of K2-18b. This leads to intriguing questions about the dynamics of atmosphere-ocean interactions and their potential impact on the planet's habitability. Could we learn something new about habitability and extraterrestrial life from its atmosphere? Typical Earth-like settings come to mind when we think of life. However, we've found evidence of life on Earth in previously unthinkable locations. Studying extremophiles, organisms that thrive in harsh environments, can shed light on potential extraterrestrial life. Deep within Earth's oceans, hydrothermal vents eject mineral-rich heated water, forming ecosystems that are both dark and teeming with life. Thermophiles and acidophiles thrive there, challenging our long-held assumptions about the conditions necessary for life. Do you think exoplanets like K2-18b could harbor similar life? Novel circumstances for previously unseen living organisms might exist in K2-18b's hydrogen-rich atmosphere. For example, methanogens, a type of microorganism that thrives in oxygen-deprived environments and produces methane on Earth, could potentially survive in such an atmosphere. If the methane in K2-18b's atmosphere is biologically produced, it could redefine our understanding of life. From the acidic Rio Tinto rivers in Spain to the Siberian tundras, the study of extremophiles broadens our knowledge of the environments that can support life. The wide scope of cruel circumstances makes us re-examine the environmental limits of life beyond Earth. As a potential exoplanet with a hydrogen-rich atmosphere and a sea underneath its surface, K2-18b is an excellent contender for studying extreme life forms. Perhaps this faraway planet is home to an alternate sort of extreme life, one that has evolved to thrive in its own unique environment. What could the transformative history of extremophiles on K2-18b be like? Complex life on Earth emerged from less complex structures that once existed as single cells. Is it conceivable that, under ideal conditions, a similar process might occur on other planets? Dimethyl sulfide, DMS, could be present in K2-18b's atmosphere, which is one of the most fascinating aspects of studying it. On Earth, this compound, which is considered a biomarker, is consistently produced by phytoplankton. Does its presence on K2-18b and other exoplanets suggest the possibility of life? After being oxidized in the atmosphere, DMS contributes to cloud formation over Earth's oceans. The discovery of life beyond Earth might hinge on the presence of such compounds in an exoplanet's atmosphere, like K2-18b. We are still in the process of testing K2-18b for the potential detection of DMS. Although such complex compounds can be identified by the James Webb Space Telescope's JWST mid-infrared instrument, their presence must be confirmed through careful analysis and expert evaluation. Researchers are thrilled about the potential biomarkers found on K2-18b, such as DMS. However, this discovery has also sparked debate, as is common with any groundbreaking finding. What DMS signifies for K2-18b remains a contentious topic among scientists. Some regard it as a promising candidate for a biosignature, while others point out that molecules with similar structures can also be produced by abiotic processes. This discussion underscores the difficulty and complexity of interpreting extraterrestrial data. Doubt has often accompanied astronomical discoveries throughout history. Initially, many people didn't believe Galileo when he claimed that Jupiter had satellites. Similarly, there was skepticism when the first exoplanet was discovered in 1995. These historical examples highlight the importance of skepticism in the scientific process. No single compound or observation is definitive in the search for alien life. Scientists are looking for biomarkers that, when combined, could provide strong evidence of life. Is it possible that DMS, along with other biomarkers such as methane and water vapor, forms part of a larger picture? Until more data is gathered, the debate is likely to continue. Evidence supporting DMS as a genuine biomarker may emerge from future missions equipped with even more sensitive instruments, assuming technology continues to advance. Does DMS hold the key to discovering extraterrestrial life, or is it merely a diversion? Regardless of one's position, the ongoing discussion highlights the dynamic nature of science. Our understanding of K2-18b and other exoplanets has been greatly enhanced by the James Webb Space Telescope, but this is just the beginning of space exploration, a long and winding road. How might technology develop in the future, and what lies beyond this massive undertaking to expand our understanding of the universe? Another revolutionary project is the Extremely Large Telescope (ELT), expected to be completed by 2025. The world's largest near-infrared optical telescope, with a primary mirror 128 feet wide, will be unveiled. Biomarkers detected by the James Webb Space Telescope may be confirmed or disproven by the ELT's unparalleled sensitivity. Findings from JWST could be complemented by data from another upcoming mission, the Large UV Optical Infrared Surveyor, LUVOIR. With its versatile operating frequencies, LUVOIR can capture direct images of exoplanets and conduct more in-depth atmospheric analyses. Advances in propulsion technology are also crucial as we aim to explore exoplanets. Ion drives and other potential methods, such as combining antimatter drives, could enable probes to explore exoplanets within a human lifetime by significantly reducing travel times. As we embark on this journey, it's essential to pause and consider the philosophical implications of our search for alien life. We are on the cusp of potentially groundbreaking discoveries. How does this quest influence our understanding of the universe, and what concerns does it raise about the future? Another mystery lies in the potential of red dwarf stars across the universe. These frequently overlooked stars may be the birthplace of life. They are fascinating hosts for planets that could support life due to their stability and longevity. If we were to confirm the presence of life beyond Earth, it would suggest that the building blocks of life are more universal than we previously thought. What if we discovered extraterrestrial microorganisms or other forms of life on planets like K2-18b? What secrets will the coming decade reveal? Will we uncover more complex mysteries that challenge our cosmic understanding, or will we confirm the presence of alien life? As we continue to push the boundaries of space exploration, the discovery of exoplanets like K2-18b opens new avenues for understanding the vastness and diversity of potential habitats across the universe. The fact that we can now study exoplanetary atmospheres in such detail marks a turning point in our search for extraterrestrial life. The combination of advanced instruments such as the James Webb Space Telescope and future missions like LUVOIR and the ELT will only enhance our ability to detect and analyze distant planets. This could lead to the discovery of more planets with conditions suitable for life. These advancements in space exploration not only provide exciting prospects for the search for life, but also refine our understanding of the conditions that allow life to thrive. Scientists are looking beyond Earth-like conditions, expanding the range of environments where life could exist. For instance, while we often associate habitability with planets that have breathable atmospheres and liquid water on their surfaces, planets like K2-18b challenge this conventional thinking. They introduce the possibility that life could exist in extreme conditions once considered inhospitable. Furthermore, the study of exoplanets like K2-18b enables a broader perspective on what constitutes a life-supporting environment. Discoveries of extremophiles on Earth, organisms that can survive in conditions ranging from boiling hot springs to extreme acidity, have forced scientists to reconsider what is necessary for life to flourish. K2-18b, with its hydrogen-rich atmosphere, is an ideal candidate for further research into this expanding understanding of life's potential. These discoveries also prompt scientists to examine the broader implications of their work, raising questions about the fundamental nature of life itself. The possibility of life on other planets could profoundly impact humanity's view of its place in the universe. It might challenge the long-held assumption that Earth is the only cradle of life in existence. While discovering extraterrestrial life would be revolutionary, it could also raise new ethical considerations, particularly regarding how we interact with and protect alien ecosystems. Encountering life beyond Earth also brings up questions about how we might recognize and communicate with other living beings. Would extraterrestrial life be intelligent, or would it take forms vastly different from anything we can imagine? As we venture further into the unknown, it's clear that the search for life isn't just about confirming the existence of alien organisms. It's about pushing the boundaries of knowledge, testing the limits of human curiosity, and exploring the very essence of being alive. The next decade of space exploration is poised to bring new discoveries that will reshape our understanding of the universe. Each new finding will bring us closer to answering humanity's most profound questions. Are we alone in the universe? And if not, what does that mean for us? With the tools and technology now at our disposal, we are closer than ever to finding the answers.